Hi guys, this is Ms. Kissinger and welcome to section 6.5b, trapezoids and kites. Yesterday we talked about trapezoids, so today we're going to end up talking about kites. First thing I want you to do is pause the computer and do this first three problems. I want you to name the quadrilateral to the most specific terms, meaning don't tell me that it's just a parallelogram if it's a rhombus. Now, the first one, we don't know any of the angles, so we can't say anything about it being a square or rectangle. But I do know that all of my sides are congruent. And if all of my sides are congruent, then I know this shape is a rhombus. Now, this shape right here, I know that two sides are parallel, but I don't know anything about congruence on any of the sides. So the only thing I can say about this one is that it's a parallelogram. And lastly, all this one tells me is that I have two sides that are parallel to each other. I don't know anything about these sides. I don't know if they're congruent. So this is just going to be a trapezoid. Now, if these two sides were congruent, then I could say that it's an isosceles trapezoid. Okay, moving on. Our first picture is a kite. Now, I have this kite, and the thing we already know is that two pairs of adjacent sides are congruent. So I know that this side is congruent to this side, and this side is congruent to this side. Now, something else I need to know about a kite is that if I were to put in some diagonals, notice that almost every single section has to do with diagonals lately. I have a diagonal here and a diagonal here. Now, if this is a perfect kite, then my diagonals are perpendicular. Now, remember, our other shapes that have diagonals that are perpendicular were our rhombus and our square. Okay, now let's move to some examples. Here's our first example. We are going to try to find the measures of angles 1, 2, and 3. And now, our property that we just learned about our kite, and we know this is a kite because we have two sets of adjacent sides that are congruent, we learned that our diagonals were perpendicular. So that means I know that this angle right here is a perpendicular angle. So I know the measure of angle 1 is equal to 90 degrees. Now, if you notice, right here, I have a triangle. How many total degrees are in a triangle? Think about it. Hopefully you said 180 because we've done this 1,000 times. So we know the measure of angle 1 plus the measure of angle 2 plus our 32 degree angle. 32 degrees equals 180 degrees. Now, I know the measure of angle 1 is 90, so I have 90 plus the measure of angle 2 plus 32 equals 180 degrees. So I have 123 is equal to, or plus, sorry, the measure of angle 2 equals 180. Oh my gosh, apparently I'm not good at math today. 90 plus 32 is what? 122. So I have 122 plus the measure of angle 2 equals 180. So now I can subtract 122 from both sides. So I have the measure of angle 2 is equal to 58 degrees. So I know the measure of angle 2 is 58 degrees. And my measure of angle 3 is going to be equal to my 32 degree angle. Okay, moving on to our next problem. We are given kite ABCD, and we're supposed to find all the missing angles. Now remember, our diagonals, where they cross, they are perpendicular. So that means that my measure of angle 1 is equal to 90 degrees. My measure of angle 2 is equal to 90 degrees. And my measure of angle 6 is equal to 90 degrees. Because if these two are perpendicular, then all of my angles are 90 degrees right here. Now I can figure out the measure of angle 3. The measure of angle 3 is going to equal 180 degrees minus 46 minus 90, because this one's 46 degrees, this one's 90 degrees, and we're going to subtract that from the 180 degree triangle. So I have the measure of angle 3 is equal to 180, and I know 180 minus 90 is 90, so 90 minus 46 is equal to 44 degrees. Now, my measure of angle 4 is going to be the same as my angle that's 46 degrees. So I have the measure of angle 4 is equal to 46 degrees. And if this is 90 and 46, then angle 5 is going to be the same as angle 3. And the measure of angle 3 is equal to 44 degrees. Okay, now, next one. This is the one that I want you to try to do it while you're at home. You can look back at the examples and watch the video again, but I want you to try to do this problem and bring it in to me on Tuesday. So if you could, watch this and have a great weekend.